So now, what if you have an equation that is not quite in standard form? We want to be able to adapt to that. So over here. So one of the things you can always tell that it is an ellipse is that between you have an x squared here and a y squared here, but you also have this addition between the two. So that addition tells you that it's an ellipse. If it was subtraction, believe it or not, it would be another shape, and you'll notice that once we get to the other shape. But this is an ellipse, and if you remember, to get it in standard form, we need it to look like this. So we need it set equal to 1, and we have to have our center up here. In this case, this center is 0. And then you got to figure out what a squared and b squared are. All right. So once you get that set, then you could graph this. As it stands now, you can't graph that. All right. So the quick step, one of the last steps you'll have to do once these get more complicated, is that the best way to actually, you'll notice that x squared and y squared are on the same side, on the left-hand side, and there's nothing else to do. You want to equal this to 1. So divide everything by 225. Okay, now what this does is you can actually take 25 divided by 225, and you'll see that it's actually 1/9. Okay, and then 225 divided by 9 is going to be 25. So what you've got is you've got yourself something that you can graph. All right, where you've got the center is now at 0, 0. Your minor axis is 3, and your major, well, your minor axis is actually 6 because it's the entire width. And then here, the entire width of the major axis would be 10. All right, even though you're counting 5 this way, and well, actually, since it's the y, 5 this way, 5 that way, 3 this way, 3 that way. Okay, and then you'd have an ellipse. All right, we're not going to graph that, but that's how it works. Now we're just going to do a couple more examples. So let me copy these down here. Let's go big. 9x squared. Oh my god, my throat is killing me. Oh my gosh, it's so rough right now. Plus 10y. Okay, now it looks like a string of junk, right? Like how do you manage this? Well, what you do is you group the y's with the y's, the x's with the x's, because what we're going to do is we're going to create a center that is not 0, 0. Okay, because you can see this guy right here doesn't just have a 9x squared. He's got some tugging that he does on the x coordinate, and then this y has some tugging that you do on the y coordinate. This 52 really doesn't belong at all. So we're going to shuffle this around so that we can actually get it to something that looks like this form. Okay. So let's put the x's with the x's, and what we'll do is we're going to put parentheses. Okay. All right, and this 52 does not really belong, so we put them over here as a negative 52. Okay. Now what you probably guessed is yes, we're going to be completing the square. This is we're going to introduce some new numbers that will be added to both sides so that we can get a perfect square that we can actually find out where the coordinates of the center of this ellipse are. Okay, now first of all, the problem with this right now is that this guy, in order to complete the square, has to be 1. So I'm going to be dividing by 9. Okay, this guy's all set. Okay. All right, now what I'm going to do is I'm going to use that little mini formula of b divided by 2 and square it. That's how we complete the square. So if you remember, we took this guy divided by 2 and then squared it, you'd actually get 4. Now we're going to add that 4 here, okay? But what we're adding over here is not 4, but, correct, 36. Why is it 36? Well, if you're going to put in a 4 in this parenthesis, this guy has been factored out, so that's technically 36. Watch out for that. Easy mistake to make. This guy we don't have to worry about because nothing was factored out. We're going to divide this guy by 2 and square it. That's 25. All right, so now we add 25 here. All right, so this guy's now ready to be parentheses squared. So you'll see that this is subtraction. So try to think of what perfect square trinomial is going to be created by introducing the 4. And it's actually got to be a -2. Because if I were to FOIL this out, I'd get a -4 in the middle, and then I'd get a +4 at the end. Right. Okay, we're getting closer. This guy is going to give us just if you just take the square root of this final number, okay? Take the square root of him, and whatever this sign is, put it there. That's how I remember it. All right, that's a plus, and then take the square root of him, that's 5. All right, let's add all these up. I do not trust my brain. Yes, I do. 61, that's 9. I'm going to do it again just because yeah, that's 9. Okay, so now we're super close to where we were in the first example. It's just now we got parentheses, but I need to make that a 1. Okay, so let's divide by 9 and watch what happens here. If I divide everything by 9, you get this really nice situation where this guy actually cancels out. So technically it's a 1. Okay, we'll put the 1 there just for graphing purposes. And then that 9 just stays there. And now what you've got is you've got it set equal to 1. You've got your center now at +2, -5. You'll go over across 1 unit, and this guy will go, oh, missed the 9. This guy will go over up and down 3. Okay, so he'll go over 1, he'll go up 3. Okay, and the center is at this location. All right, one more. We're at the 7-minute mark. Okay, we're all right. We're all right. I can do one more. I got one more in the tank. And I'm going to go hibernate by a vaporizer. Last one. I love this stuff, though. I just like conic sections. They're kind of beautiful. I'm going to go hibernate by a vaporizer and just dream about ellipses and hyperbolas. Infinitely large parabolas. Okay. All right, so now, so now it's completely messed around. Over here, you know, we had it equal to 0. Now we got some equal to a bunch of stuff, but don't worry. You know, you put the peoples with their peoples, and that's it. You know, just juggle this so that you are leaving this outsider here on the side by himself. All right, so let's go 25x squared. I'm going to move this guy over to the other side for a positive 150. Then, okay, we'll do that. And then we're going to go plus 4y squared. We're going to move that 16y over there. Leave a space there. And then we're going to leave that 159 right there. So all we did was move these two guys over here and left the 159. That's something that you know, when we were working with quadratics, we always dialed it to 0, but not with these. These are going to be different because we need a 1 there in order for it to be quote-unquote graphable, okay? All right, let's factor out a 25 out of this because that needs to be 1 in order to complete the square. What is that, 6 times? 150 divided by 6, yeah, 6 times. Okay, leave that space. We're going to divide by 4. Okay, leave that space. All right. Okay, so now just the 6, we're going to focus on him. Divide by 2, square it, that's 9. 9 times 25, I don't know what that is. 225. We're going to add 225. All right. Common mistake. You might forget this guy, so watch out for that. Divide this guy by 2, and square it, that's plus 4. You'll notice the same kind of numbers pop up all the time. That's just how it is. It's a result of that formula. So now we got 16 being added here. So it's going to give us a big number, but that's okay. We're going to divide by it and set it equal to 1. So now we got 25x plus 3 squared plus 4y minus 2 squared equals whatever all that stuff is, 159 plus 225 plus 16. Get an error. Oh yeah, I got a bunch of parentheses and stuff. So let's try that again. Oh my gosh, we're dying. 400. All right, that's beautiful. All right, 400 is a perfectly round number because now I'm going to divide everything by 400. 400. All right, again, I don't trust my brain. 400 divided by 25 is 16. That's going to be 100, and that equals 1. So now this is totally graphable. You got a center at -3, +2. You're going to go along the x laterally. You're going to move 4 units, and then up and down you're going to move 10. All right, and that's how we graph it. All right, have a good day, everybody. Have a better day.